Hello everyone, this is Bradley. Today this is a continuation from last tutorial in which we're discussing the creation of this procedural Christmas light setup. Last time we are actually making a setup for a single Suzanne head. And today we're going to move on for a setup which is applying for multiple objects. So for example, if I have 3 Suzanne heads, then because this setup only works for a single Suzanne head, so what's very likely happen is we need to shift the D to duplicate this entire node tree for 3 times. And it will definitely make our life suffer. And that's why we are going to use a feature in animation nodes which is called a loop function. So that we, for each Suzanne, we're going to do everything procedurally. And considering about the fact that we're going to move on to work on the text object, you never know what kind of, how many characters you're going to have in your text paragraph or other things. Then it will be very good if we're making everything procedural here. Okay. And that's why basically we're going to use the loop function. And here is a single setup. It's very possible that you put everything into this single loop. But you can see I have to zoom out very much so that I can show this entire node tree. It's not very easy for me to teach you. Also not even easy for me to actually read this entire node tree working in such a way. So to make our life very convenient, I'm going to break this node tree into 2 parts, basically half-half. Before we actually move on, I would like to recap about what we have actually accomplished last time. Basically the point is we generated a spline mesh and we use a shrink wrap modifier to wrap everything onto a single Suzanne head. And then we're going to use these wrapped vertex points to regenerate spline. On one side we're outputting this spline, on the other side we'll use that as a guidance to instance or scan points so that we can put our light bulb and the lights onto these points. And this is basically all about it. So talking about how to actually break this node tree into half. I think it will be simply easier if we break up from this point in which we're generating this spline, because a spline needs to be done for each text or for each object at least, so that you must not actually generate everything earlier before, so that you must not cut off our loop before. Okay, so what we need to do next is basically go to our most initial loop input, and I'm going to take a spline list output. And we simply move this spline list to the back. And we're going to put these splines into spline, and immediately you will see all this kind of red bar. It actually means the errors in animation nodes. But don't necessarily to worry about this, you just cut off the splines later. The reason of this error is because the object instance node cannot be into the subprograms. So you have to cut off the loop somewhere there. And simply select the node, hit E, and you can select the network. So now we can actually put that up and down, which makes the node tree very much cleaner. So now this entire pinkish group becomes a single loop. And what you can do is you can put all these kind of parameters. So you can hit the use, go to socket settings, put the input in the flow. You can put all these kind of things into parameters. So basically the control you want to get into the parameters. Is there any good controls that we can potentially play with? Probably no. I think this is all about it. You can also put all this kind of rotation into place, but I don't think I'm going to do that at this moment. If you don't add iterator, because I think at this moment we don't necessarily do anything. I'm just going to hit W goes to right, then we're invoking subprogram. We can name that as a spline unit. Probably not a very good name, but anyway. Then we put this spline list back to place. If you directly plug that into the curve object output, then it will work. But remember, when we are using this instancing on spline, we're using the loop version. But this is actually not right, because the loop version can only receive a single spline while we're actually outputting the multiple splines. So you need to change everything into the instance on spline list versions. We have a list later. So now you can actually put these splines back to place, and then it will work. If you do not do that, then you directly plug that into the loop version. Then it will give you a get list element node, which does not mean anything. Simply means an error. And this is about it. So now I can use these vectors to replace kind of all the outputs. By the way, whether you use the vector or matrices into this get list length does not really matter. So they're the same in this case. So now we have successfully break up everything into two places. And if you simply get these iterations, then it works. But the issues that we're actually getting is this shrink wrap. We need to actually define this shrink wrap targets for each object that we're actually creating. And what makes things more complicated is that I do think you realize, so let's rename that as a line mesh. So we have a single line mesh and a single shrink wrap modifier and a single target. But assuming if we are working with 3 Suzanne heads, then I need to actually duplicate this line mesh for 3 times. For 3 line mesh in total, and each line mesh should have its own target. So target to that and target to that as well. So this makes things more chaotic, and to make things more procedural, then we need to actually generate, we need to be able to procedurally instance this line mesh as well. Okay. So we're going to make things a little bit complicated. So let's firstly take all these kind of things which were not needed. So light, camera. Well, let's just delete the entire hierarchy since we're not going to work with these collections. I'm going to put the bonbons into hide because I don't want to see that. And we have this line mesh, just to move that out of things. Delete our point light, which is not needed. And I want to leave this collection. Let's name that as a wrapping target. I want to leave these collections only with the Suzanne head target that we're going to have. And then this is splines. This spline probably not. I'll keep that for the moment. So now we have 3 Suzanne head within these wrapping targets. And I'm going to delete the rest of the 2 because I want to firstly work with a single Suzanne head to make things easier. Then let's go into our loop. In the iterator, we need to actually take the object list so that we know that if we have 3 objects from the collection, then we're going to iterate or calculate this entire loop for 3 times. And firstly, I need to name the first mesh list, first object list into generated mesh, because we need to generate this line mesh for 3 times for 3 Suzanne heads, and so on and so forth. And for the second iterator, we're going to take the object list again, but this time we're actually going to define the modifier target. Modifier target. Okay. And since we're actually generating the first mesh, since we're generating mesh use the loop, we'll just take this generated mesh to the mesh object output. Then what's about the mesh target? So we're using animation node to define this target. And as I explained in the last tutorial, I'm going to use the concept which is object attributes for all this kind of setting which is not defined directly directed from the animation node. So I'm going to put this object target into values and explained in my last tutorial, just right click, copy the path and paste. In this case, since we're directly work with modifier and constraint, so everything is blue and all this kind of orange, that you don't need to worry anything about take the other, how should I say, statement. You just directly copy data path and it will be fine. Okay. And I think it does not really matter where you put these nodes, but usually it's recommended to put all the cloud nodes in a series so that the animation nodes really knows which function to operate first. So we created the mesh first, and then we are directing the modifier target. If you don't have a mesh, then you cannot actually create an have an object to put this modifier on. So this is the point. Okay. So now we have two. So now we lose the iterator and we have the generated mesh list and the modifier target list instead. But now our setup hasn't been completed yet, and I will show you why. So let's firstly increase this interval so that I can reduce the stress by increasing the Suzanne head. So let's just duplicate this Suzanne head and move that away, execute the node tree, and you will realize we do have a line mesh being instanced on being wrapped onto the Suzanne, but it's not as well as our first Suzanne. And the reason is that our spiral is always generated at world origin. And for this spiral, which is generated here, and you are asking that to wrap to a Suzanne head which is very far away, so that you will actually wrap into a place which is just the nearest vertex, and it causes the errors. So it means that what we need to do is that we need to actually move these spirals to be generated at the same location where our Suzanne head actually locates. So in this iterator, I'm going to take the object matrix, to take a matrix list. And since we're going to move our spiral, then I'm just going to use the same transform vector, just to duplicate that and put that later, and put the matrices, the orange into orange. Very simple. Don't really think that it's too complicated. Okay. So how can we actually know the matrix? So we need to know the matrix of our object. So let's simply just take object matrix input, put objects in, and the matrix out. Then we have everything perfect. This is a complete procedural, and you can definitely duplicate one more Suzanne head. And let's execute this node tree. I don't know why, but you have to execute this node tree 2 times in order to make everything accurate. I think maybe because we are actually involving the modifier. When you firstly create a modifier, it's not very well calculated about how it wraps onto objects and so on and so forth. But basically, just I suppose when you are working with this setup, most of them should be static. So I don't think you need to worry about this execution. Otherwise, I don't know how you can actually solve this problem properly. But this is currently the state of it. So now we have finished the setup for multiple Suzanne heads. It does not necessarily be the Suzanne head. It can be any other things. A cylinder, a donuts, a cup of coffees. I don't care what it is, but basically this is the setup. Next step, I would like to move on to the text object. So before we work with text object, we first need to actually generate the text. So there are 2 ways of thinking. One is to use a separate text object node. The other is actually use the decompose text object node. This node is decompose text node is created to replace the old workflow with the separate text object. So in most cases, you don't need this, and you need this decompose text object instead. And there is a very strict workflow, a template workflow that you have to work with these nodes. You need these many nodes: object instancer, text object output, and object matrix output. You also need a font input. It's probably a little bit complicated to really remember and to call these nodes, but this is really how it works. So you put the transformation into transformation, orange into orange, blue into blue, black into black, and white into white. I think this is the easiest way that you can remember. So what about a green? You put a green to gray. But you can also ask, okay, why don't I just generate font width in this case? The reason is because you need to synchronize the font in decompose text to the font that you generate later. And I'm also going to turn on bevel depths, the things. Yeah, I think this is fine. So I'm going to activate the font, put the font back. Otherwise, when you generate a text object, it'll always use the B font. And we're going to just select the font that we're going to have. So this entire functionality work best with the monospace. Actually, it will only work with monospace. Otherwise, it will cause errors. So you can check Wikipedia for monospace fonts, but usually in Windows you already carries all these many monospace fonts. I'm just going to choose whatever ones that will work. So let's just choose IBM, which looks fine, and I'm going to type a single H. The reason to type this single H is, as I said earlier, that you always work with the simple setup before you move on to the complicated one. And then I'm going to delete all these kind of Suzanne head for the moment. I'm not going to use the copy sources. It's not necessary. You can directly generate text from everything. Then it's just, yeah, from now on we're supposed to have a single object. Then I'm going to take the horizontal and the vertical aligns so that I align everything. You can actually change all these kind of sides, but you also need to change the size here as well. There's word space, line spacing, alignment. There are a billion things that you can play with. I'm just going to take this as a center. Okay. There are a billion things that you can potentially work with. I don't want to spend time in discussing about that, but it's actually really all about it. You can test it by yourself at some point. Okay. Then you can change that to P as well. I don't want to make all these kind of characters facing upwards. So what I'm going to do is simply just put a offset matrices and rotate that 90 degrees on Y, and I'm going to change the rotation into local axis. Doesn't seem to be right. Yeah, X axis. Now everything's fine. I'll probably keep that as left. I don't actually really understand how that works, but anyway. So now we have actually created all these kind of things. We're going to start with link this text setup to the multiple mesh setup that we have created earlier. To replace the new setup with the older setup is actually not very easy. The reason is that now we have this line mesh and a shrink wrap modifier. If I put this target to select this text object, and you can see that does not really work. So basically what happens is our modifier does not really recognize the text object. This is a Blender limitation which makes us suffer. So it also means that we have to regenerate the mesh from all these kind of things. So to regenerate the mesh, I'm going to use the object mesh dot to read the modifier target, and the modifier target will be our text object. So let's firstly replace whatever we have done. So orange goes to orange. The reason I don't rotate the orange before the input, because I only would like to rotate this text but not our spiral, especially when our spiral is already kind of vertical, right? So, and I'm going to use the new text object into the get list length. So we no longer need this collection informations, and basically just to keep it as it is. Now it actually has been fine. So, but now we regenerate all these kind of splines, but we are not having our the shrink wrap back, because as I said earlier, it does not really recognize the text objects. So we have to regenerate the mesh. So where can we actually put this regenerate mesh? We need a new object list within this iterator. And I'm just going to call that text mesh. I put a text mesh into the mesh, and I'm finally going to output this new generated mesh into the value to replace the value that we have earlier. And then we actually need to input things into this text mesh. What you simply can do is just duplicate these object instances and not copy from sources to generate the empty mesh object in text object. So now everything has been actually back. So we have a very nice wrapping on the P, the reason we do not have light is because the interval is being set too much. So let's just keep it as 2, so now we have a single light bulb. You can actually control the size later, or you can increase the size of our text, but basically you can play around with all these kind of settings. You can also actually extrude and even bevel our text objects if you want to make our text more stylized or whatever. It's really like some kind of interesting whatever. And then because this is very procedural, so you can just type the text procedural. Then we generate everything back procedural. Although the light bulb is actually too chaotic, but you get a kind of idea. Now I want you to realize, because we at the same places, we do not only have this a single a text object, but also a mesh object. So even if you hit H to hide a object, the P will still stay in place because there are actually two objects overlapping each other. I don't know in render if you will actually cause the Z fighting or not, but probably a better method is basically just the object visibility output and put that into place and just hide everything in viewport, so that the text object will be hide, but only the generated mesh will be kept. So this is one way that you avoid the Z fighting, or you maybe just test that in render whether you have Z fighting or not, but anyway, it does not really matter. Another thing I want you to realize, if we are going to test a kind of sentence like a H and H, then you can see we have two wrapped spline, but a additional spline that has been generated. So the reason is because even if we know that this is a space, which means actually an empty, but we are still generating a transform, and we are still generating an object as well. So finally, we are putting a spline into the place, but we don't have any objects to wrap on. So we end up having just a spiral without anything wrapped on, onto. And to avoid this problem, there's many different ways, but I think the simplest way is to use a function in the loop, which is called condition. So for the condition, basically, if you hit Control H, so you are unhiding all this kind of socket. If you turn off this condition, it means we output nothing. But if you turn on the condition, then we output something. So we need to define when we're actually not to output the splines and when to output the splines. And there are many different ways to actually determine these kind of conditions, but I think the easiest way is simply that when we're actually putting a text into mesh, if there is a space, which means there is no mesh, it means its vertex location, it means 0. There's no vertices exist for a space. So you simply just take a compiler numbers, and we're going to get a list length. Put the length into place, and you can see that if A is larger than 0, then we should output things output our splines. So once you have done that, we lose our spiral, which has been generated for our empties. And this is it. And the final thing that I would like to discuss is how can we actually talk about the text block. So within the text block, so let's go to text editor. Let's just create a new text. The reason we use the text block to do the stuff is because you cannot directly hit enters to make the different lines of text. So if you would like to type different lines, then you have to pick that. So let's just hit A, B, C. So 3 characters in 3 lines. You cannot do that in this text object. You have to use the text blocker. So we're going to use the text blocker reader. Text blocker reader. And within our text block, let's just name the tester. And let's turn our tester and put the text inside. So now we have all these kind of A, B, C. So the reason it looks kind of very weird is because that we rotated this object earlier. So I think global axis, local pivot. Yes, we're going to try to turn everything into global axis, global pivot, which solve the every edge issues. And I'm going to turn the alignment into centers. So now you can take a happy just a test. And the reason it does not immediately change because the text blocker is not a part of trigger. So we have to execute this node tree for 2 times for the accuracy. So you can see it's just a test. Unfortunately, up to this part, we still haven't really finished. A last thing that I would like to actually discuss is previously when we actually working with all these kind of orientations. Orientation is based on the word origin. But now since we're actually having separate objects, then you probably realize the orientation should be based on the origin of each object. This is something that I forgot to actually discuss earlier, which is kind of very important. So we actually need to break up the second part. So basically this part into a second loop. But we also cannot put the object instance into the loop. So what we need to do is basically just keep objects matrix. So we're going to use the loop to generate all this kind of matrix. So this is the part that we're actually going to take before I actually move on. So we're going to make a loop for this part. So to make a loop, I'm going to select this node, hit W goes to right, loop through spline list. Put the spline list into place, and I'm going to take a matrix list. And take the matrix list into matrix list, so that we are going to decompose the matrix because we only need the locations, translation as the origin. And we're going to feed these splines into spline, but since we're working with the loop again, so we need to take the instance thing on spline loop. So now we're actually going to use the vector instead. This is kind of making life very difficult sometimes. So use the vector, replace these points, and I'm going to delete these instances. And when talking about directions, this is the very tricky part that we have to think about. So what's the direction it should look at? We're going to use a vector math to subtract the locations. And finally, we're going to, in generator, we're going to add a matrix list. And output this first matrix list, and we're going to output the second matrix list. So basically just duplicate a new matrix list. The first one is for our spiral, the first one is for our bulb, the light, and then second one is for our light. Okay, and within our these kind of how should I actually call this? So let's just move all these kind of things together and use S to shrink. Okay, matrix into instances, matrix into place, and because amount of light it should be synchronized, so it just use this a single get list length is good enough. Now everything should be not really done properly. No, this subtract function should be actually right, because I've discussed this direction rotation node. So I think the issue is actually not the this subtract function, but rather the matrix list that we input. When we look at the matrix we have input, it's actually the original matrix. But as we struggled earlier, it should be the matrix that we have rotated. Because if we don't rotate the text, everything just facing upwards, and then we rotate everything, the matrix has been actually rotated down, and this is how it works. And now you can actually decrease the intervals so that it increase amount of light bulbs, and also decrease the size, and you can decrease these lights. So there are lots of things that you can potentially set. And if you would like to deal with the random colors, I think you can take the random color directly. So there is a random color node in animation nodes, but you don't have actual settings talking about this random color. So I have my own preset, which is random color, random color loop. I think this is not a version that has been included in your library, but it should be something similar. So you can use either of them to do the work. So now I have a kind of greenish whatever. Very weird, but it's fine. So you can take that into lists, feeds, and whatever color that you get. Anyway, you can basically try to work with these things by yourself. And I think this is all about it. You can also play with this, because I think this setup is actually too crowded to each other. So you can actually work with character spacings like 1.5, line spacing, word spacing, whatever that is things that you would like to play with. This is basically a procedural setup. So I don't want to spend more time teaching this entire thing. It looks kind of complicated, but if you really understand the step that you are doing, you probably it's not really that very difficult. And this node is still kind of very nice. I tried my best to explain everything. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.